So we'll be looking at matrix multiplication. So let's start from the first simple one, which is multiplying a constant with a matrix. All right. So given a matrix A, which is A11, A12, A21, A22. All right. So we know that this is a 2 by 2 matrix. So what we are interested in is finding the constant, the product. Let's call this product B, and it equals the constant times matrix A. Okay. So what we are doing is literally just multiplying K with matrix A. So that's K. So for our matrix we have A11, A12, A21, A22. Okay. So this is now a 2 by 2 matrix being multiplied with a constant K. And what P is going to be is just element by element multiplication of the constant K with matrix A, so which is K times A11, K times A12, K times A21, and K times A22. Okay, so this is just a new matrix which is produced by multiplying a constant number K with matrix A. And as you can see, so the dimension of the new matrix B itself is 2 by 2. Okay, and then multiplying two matrices. So let's say we have matrix C, an M by N matrix, and another matrix D, an R by S matrix. So M by N is the dimension of matrix C, and R by S is the dimension of matrix D. Now we are interested in finding what's, let's say, a given matrix E, which is, let's just write it here. So interested to find matrix E, which is a product of C times D. Okay. C times D. Now, matrix multiplication requires the following two important rules. First one is that the column of the first matrix, okay, in our case matrix C, must be equal to, all right, equal to the row of the second matrix. Okay, so in this case D. Yeah, so the column of the first matrix, matrix C, must be equal to the row of the second matrix. So this is for a product between the two exists, specifically in this case C times D. The column of the first matrix must be equal to the row of the second matrix. Now, by changing C and D, so we can ask ourselves now if CD equals DC. If C times D is equal to D times C. So in this case, now we have said that we will require the column of C to be equal to the row of D, but in this case it's the column of D to be equal to the row of C. Okay, so these two are not equal. These two will not be equal. Yeah. These two will not be equal because the requirements are different. Now the second rule is therefore if E exists, okay, if E exists, the dimension of E is m by S. Okay, so this m, so this m here, m by S. So we are requiring n to be equal to R. Okay, because that is the column of. So in this case, we're requiring R. Okay, you can write here that is n should be equal to R. Okay. So therefore, if matrix E exists, which is C times D in our case, then the dimension of A is m times S, or m by S. Now let us just spell everything for these two matrices. Let us write their elements. So in the first case, C is C11, C12, C13, C21, C22, C23, and C31, C32, C33. Okay, so we have these two matrices C and D, and our D is D11, D12, D13, and D21, D22, D23, D31, D32, D33. Okay. Now, so our matrix E, which is a product of the two, so E is C times D. So we write out first C, which is C1 times D11. Okay. Right. Now we know that this is a 3 by 3 matrix, and this also 3 by 3 matrix. Okay. This is just coincidence. All right. So we could have taken any matrix with any dimension. So all we have to check is that the column of the first matrix is equal to the row of the second matrix. So that's what we have to check. So if that matches, if the column of the first matrix is equivalent to or equal to the row of the second matrix, now we can go ahead and do that multiplication, and the result will be S3 by S3. So a row by column. That's what we're expecting. Okay. Now, so the product of this is going to be what? This is going to be E11, E12, E13, E21, E22, E23, and E31, E32, E33. Okay, so that is what the product is going to be. That will be the product. But what are these E's? Now, so what are those elements in there? So E 1 1. Now, as we have said, so each descriptors here, each designators in the subscript are trying to tell us. The first thing is telling you where it is. That is in the first column and first row and first column. Yeah. Second row and second column. Third row and first column. Yeah. So in the same way, that also tells you that is in the first row and first column. But on top of that, that tells you where it's coming from. So E11 is coming from the first row of the first matrix multiplied by the first column of the second matrix. Okay. So what are we saying? When we say 1 1, E11 is coming from the first, yeah, the first row. That's the product of the first row and the first column of the second matrix. Yeah. So we'll add, we'll multiply and add, multiply and add until we exhaust all elements in those row and column. So how does it go? So this will go C11 times D11 plus second C12 times D21 plus, we still have one more, C13 times D31. Okay, now we continue like this, right? And let's work for E23. So E23 will be the same. It will come from the second row of the first matrix multiplied by the third column of the second matrix. Okay, so we're looking at the second row is 1, okay, multiplied by the third column of the second, so which is that. Okay, so we are looking at those two. So we start again by multiplying C21, which is that one, multiplied by D13, D13 plus C22 multiplied by D23, and the last product C23, I guess C23 multiplied by the last one D33, D33. Now we can go like this, but by looking at these two products, now we are able to find out some correlation. Now if you look at this, so for 1 1, for product 1 1, we have row of the first matrix is identical with the column of the second matrix, so 1 1 1. So in the second designator we have 2 4 the row and 3 4 the column. So if you see this 2 3, so those 2 3 is also, that 2 3 will also be identical throughout. So it goes for the second row of the first matrix and the third column of the second matrix. Okay, so again this, but the internal starting from 1, those the internal numbers will start from 1 and increase up to n, yeah, and goes from same way 1 2 3. So the external numbers follow which elements they are indicating, and the internal starts from 1 and it keeps increasing, okay, by 1 up to you have added enough elements with the number of column of the first matrix or the number of row of the second matrix, which are equal. Okay, so what type of correlation therefore do we see? So if you have E let's say ij, I standing for rows and j standing for columns. So what we are looking at is you'll be multiplying c I1 d1j plus c I2 d2j plus c I3 d3j, and it continues. Okay, so we can generalize that. So e ij is really the sum of all c I n times d n j's, and running from 1 to capital N, where capital N is the number of column of the first matrix. Okay,
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.